How fast does a car need to drive on Earth to simply leave the Earth and enter space? Or what about when you throw a tennis ball straight up into the air? How high would it go? These are the type of questions we can answer with mechanics. And to start our study of mechanics, we are going to study some simple straight line motion first. You probably already know what distance is. For instance, if a car moved from here to there, it would have traveled a certain distance. Now, displacement is distance in a given direction. To understand this, let's first construct a coordinate system. For now, a simple x-axis will do. If the car goes from 0 to 1, it will have traveled a distance of 1 meter, and its displacement would also be 1. But if the car reversed by 1, then the distance it has traveled would be 2 meters, but its displacement would be now 0. Now let's say if the car then traveled forward by 2 distance, then it would be 4 meters, but the displacement would be 2 meters. In a sense, you could say that displacement is the distance between the car's starting position and its ending position. Now, velocity is very similar to speed, but just like displacement is distance in a given direction, velocity is speed in a given direction. But since the motion is in a straight line motion and there isn't much direction involved, it is going to seem very similar to speed, except maybe a negative sign here and there. For example, if the car moves back by 2 meters in 1 second, its speed would be 2 meters per second. But its velocity is minus 2 meters per second, as it's moving backwards. And if it were to move forward by 1 meter per 1 second, its speed and velocity would be the same at 1 meter per second. Since it's a straight line motion, there isn't much difference. But when we talk about 2D motion, it'll become more clear, but for now that's all that we need to know. Just like velocity and speed are the change in distance with respect to time, acceleration is the change in velocity with respect to time. To understand this, we are going to change the x-axis to represent velocity instead of distance. So, when the car moves forward by 1, it actually means it has changed its velocity by 1. Also, calculating acceleration is similar to calculating velocity, as it's simply the change in velocity divided by the change in time. So in this case, the change in velocity is 1 meter per second, as the velocity went from 0 to 1, and the time taken is 1 second, so the acceleration would be 1 meter per second squared. Those are the very basics of mechanics, and hopefully in the future, we will be covering more, such as projectiles and circular motion, but for now that's all that we have time for today. Thanks for watching, and don't forget to subscribe for more videos.